Okay, when you look at this problem, it's really complex. And what I heard was Pivnert, or Chem 111, ideal gas law, PV equals nRT. So that is something that will help you with one piece of the problem. So let's go ahead and use that piece. What are we going to do with that piece? Oh, this is a typo. Get rid of that little c, okay? What are we going to do with the ideal gas law? Find the moles of what? Find the moles of carbon monoxide. Okay, so we'll start by working on the carbon monoxide. What do we know about carbon monoxide? Pressure is 0.177 atmospheres. What else? Volume is 2 liters. Anything else? Temperature, 25 degrees Celsius. We have to change that to Kelvin, 298 Kelvin. So now we can use the ideal gas law to solve for the moles. So the moles of carbon monoxide is equal to PV over RT. My pressure, 0.177 atmospheres, times my volume, 2 liters, divided by the gas constant, 0.0821 liter atmosphere per mole Kelvin, times 298 Kelvin. So N, the number of moles of carbon monoxide, is equal to 0.015 moles. Okay. So now I'll set that aside for now. Now what do I do? Do what? Grams of water to moles of water? Okay. I'm going to leave some space for carbon monoxide in case I want to come back there and do something else later. So now let's look at the water. I know that I have 0.391 grams of water. I'll change that into moles. 18.0148 grams. And so I've got 0.0217 moles of water. So I'll save that. Now I know the moles of each of my my two products. Now what do I do? Sure, why do I want to do that? Okay, let's set up our ice chart for starters. Or we'll that up in a minute. Let's write out our expression. Okay? Let's write our equilibrium expression. What does that look like? Oh, where do I get K sub C? I do? Can I? Do you think so? I think you're right. Why not use K sub P when that's what I'm given, and what else is this? It's all gases, right? Do you really want me to brush up on my algebra? Oh, we know K sub P is K sub C times RT to the delta N sub G. But why do you want to do that when you have all gases and you have K sub P? I don't want to do that. Do you? You like to do more work? There's enough work in this problem, believe me. So let's use Kp. Okay? So Kp is equal to the pressure of carbon monoxide times the pressure of water, because it's a gas, divided by the pressure of my formic acid. Okay. Now, if I'm going to set up my ice chart, what do I need? Not concentrations. I need pressures. And I could have done it with concentrations, but it would be a lot more work. Okay, so let's set up our chart. And these are all gases. I'm just being lazy. Okay, what's my initial pressure? What goes in the I line? What goes in the I line here? 0, because I don't have any, because I loaded in. Okay, now I heard something. How am I going to fill in the rest here? What goes in here? Where was that 0.177 from? That was measured at 25 degrees. What did I do as soon as I loaded these two materials in there? I heated it up. I told you this was fancy. What's the pressure now of carbon monoxide? You can. Yeah, we can. You want to do that? I think so. I thought there was an easier way than doing it once. We know that we have carbon monoxide in a container at 25 degrees C. The container is sealed. We heated that container up. What's the new pressure? Go back to Chem 111, the baby gas laws. Pressure, temperature. Remember Charles, the balloonist? Remember? Robert Charles was a hot air balloonist. That was his hobby. That's how he did his pressure temperature studies. P1 over T1 equals P2 over T2. Personally, I think that's easier. Okay? But we could do it. I mean, we already did the ideal gas law because you wanted to. So let's do it this way now. P1 over T1 equals P2 over T2. So I have 0.177 atmospheres at 298 Kelvin equals P2 at 400 Celsius, which is 673 Kelvin. So when I solve, P2 is 0.400 atmosphere. Now, I could have also used PV equals nRT, but I thought that was faster. So now, this goes in the chart for my initial reaction temperature, or not temperature, pressure. So for my I. So my I for carbon monoxide is now 0.4 atmospheres. Now what? Now we got to find the pressure for the water. So how are we going to do that if we know the moles of water? Now we're going to have to use PV equals nRT, right? So we know PV equals nRT. So my pressure is equal to the moles, 0.0217 moles, times R, 0.0821 liter atmosphere per mole Kelvin. What's my temperature? 673 Kelvin, divided by my volume, What's my volume? 2 liters. So my pressure for the water is 0.6 atmospheres. Now what? Now I can put in my values, okay? So I'm going to put 0.6 atmospheres here. Okay, can you finish this problem now? Okay, go ahead and finish this problem. Oh, you can't use a calculator. Okay?